Genius bar time. Genius bar time. They'll give you a new one. They think we should get.
What are the stars?
It's for jabber scribes. What's the difference between a note taker and a jabber scribe? They're different.
Oh, this is like in school. You get
Yeah,
a
we're
star?
supposed to. Does anyone want to be a jabber scribe? You get a star. Yeah. Well, we have a sign up here saying we should hand out stickers. Okay. All right. I think we're ready to get started. All right. So welcome to the ISIS working group. We're a little pressed for time today with the 2.5-hour Friday slot. That's a joke. Here's our note well.
You have to read it?
By participating with the whole thing or just the bold?
No.
By participating with the IETF, you agree to follow the IETF processes. If you are aware that a contribution of yours, something you write, say, or discuss in the IETF context is covered by patents or patent applications, you need to disclose that fact. You understand that the meetings might be recorded, broadcast, and publicly archived. I believe this one is. Okay. For further reading, you can go there. So this is our agenda today. Does anybody have any additions or subtractions? All right, so let's get on to the status of where we're at. So we've had 2 new working group documents. Admin tag actually managed to rev once since the 00 listing, since the last meeting in Honolulu. A lot of these everyone should be familiar with. The ones in bold on these slides are being presented today. Any comments on those? We were a little bit lax on our TE metric extensions, so that's completed last call. We just need to push it through. And extended sequence number should be completing IETF last call soon, I think. We have some new IDs. So look for these on the list and maybe give some guidance. All of the updated IDs are being presented today. And then we have some existing stuff. Some of these are sort of just waiting to time out, like the critical sub-TLD. And since the distribution trees, we'll push that over to multicast. The source routing and AutoComp are pretty much related to HomeNet right now. They're not restricted to HomeNet's use, but well, AutoComp is, but source S routing isn't. And these are the ones that are about to fall off. If you go to data tracker and type ISIS, this shows up. It's worth reading, I guess. It was referenced to, it's the security analysis for ISIS. Primarily, this is, I think, where the extended sequence number work came from. Okay. So I think the Yang was first. You're nice organized one.
Okay, so I'm Stefan from Orange. I will present you the update regarding the ISIS Yang model. Next slide. So in this new version, we introduce the ISIS node tag. So we are able to define within the ISIS instance a list of node tags that could be applied to this node, and it's also applicable to the multi-topology use case. Next slide. We are also modifying the authentication. So based on the keychain model from AC, we are introducing the ability to use a keychain reference, so towards the keychain model, and also in order to simplify the authentication between all the routing protocols, we are currently using some groupings coming from the keychain to not redefining all the possible authentication algorithm. So it's inherited from keychain. And as AC already mentioned during the RTGWG, if an implementation is not supporting, for example, SHA-1 for a specific routing protocol, it is expected that the backend will reject the configuration. Next slide. We are also introducing fast reroute, so IP fast reroute configuration. There was a lot of debate on it. So what we are proposing here, so it's a support of LFA and remote LFA. Remote LFA is seen as a child of LFA, so if you want to activate remote LFA, you will have to activate LFA first, and the activation is only done per interface. So next slide, so you will see how this is the global configuration. So what we done globally is just creating containers, but these containers are empty and just there for augmentation. So we can think about, for example, let's vendor augment this container using, for example, LFA policies. So the global configuration is really not to activate LFA. So next slide. So next slide is the interface configuration for fast reroute, and here you have the ability through the enabled keyword under fast reroute LFA to say, okay, I want to activate LFA or remote LFA then under the interface. Next slide. There was also some addings regarding Spring. We are currently under discussion about what should be kept in this ISIS Yang model and what should be in the Spring segment routing Yang model. So currently the situation is not clear, so there are some redundant information between both models, but we hope to clarify this quite soon. There was still the discussion between the VRF-centric and protocol-centric, which was the discussion of the week. And the status now, it seems that there is clear consensus to go to the VRF, so routing instance-centric model. So there was a discussion on NetMod, there was a discussion on RTGWG, and it sounds that the consensus is there, so we will update the model accordingly. Next slide. So the next step in terms of configuration, we pretty think that we are done, but we are clearly welcoming comments if there are some critical pieces that we missed. We are starting the review of the operational state. So we are currently trying to align both configuration trees and operational state trees, which was not the case before. We are also progressing in terms of alignment with the OSPF model. So now we are clearly requiring your feedback because we are working in a design team, but for sure we need your feedback about do we miss something? Is it fine for everybody? So please comment what we have done. Thank you.
Any questions? Okay.
Good morning, everyone. I'm János Farkas, and this is a presentation on the recent ISIS PCR draft. We have a new author, Chris Bowers. Welcome, and thank you very much for your help in this draft and in this subject, actually, in other drafts. Next slide, please. This is just a quick recap what it is. It is, in fact, an extension to SPB, shortest path bridging. The goal is to move beyond the shortest path capabilities provided by SPB by means of having so-called explicit trees. This figure illustrates these two types of trees. The blue one is the shortest path, and for exception traffic steering, in some cases we may need explicit trees. This is for small networks and for rare usage. One important thing is that there is no protocol change included in this work at all. It is just new TLVs, actually. Next slide, please. The status. It is we are developing the work in two SDOs here and in IEEE 2.1. The corresponding .1 document is QCA, .1 QCA, which is entering the sponsor ballot, which is the highest level ballot in IEEE. We expect to have 2 cycles at this level, and if everything goes optimal, the final approval could be in July. QCA has 2 normative references to IETF drafts, working group drafts. One of them is here, the ISIST metric extensions, and the other one is the MRT FRL algorithm. And for final approval, QCA cannot be approved without referring ongoing work. So actually, QCA can be only finished when they become RFCs. Also, we need ISIS TLV code points, and this is one of the main goals of this draft I'm presenting here. Some words on this draft. This is in sync with the most recent QCA draft and actually has moved beyond. Next slide, please, and we will see the details. This ISIS PCR draft has been evolving as QCA evolved. At the last IETF, I presented the 00 draft, and this is 02. There was an intermediate draft which was for bringing it sync, the ID here, with the QCA updates. This one includes the updates of the QCA draft 1.4, and actually have moved beyond. The first bullet summarizes these updates that happened in the QCA document. We wanted to simplify and found a way to simplify the topology sub-TLV, which is the main sub-TLV we are defining, at the price of burning the so-called explicit algorithm IDs. So that's why the first 2 changes, the ECT algorithm for the loose tree and the loose tree set has been changed, the topology sub-TLV has been changed, and there is also a change, a new flag in the bandwidth assignment sub-TLV, and a new sub-TLV, the timestamp sub-TLV, which is for sort of conflict resolution if something goes wrong. And as I said, this ID, ISIS PCR ID, has moved beyond the QCA draft. I've got comments from a number of people which are included in this document already. So we wanted to bring the draft for this meeting in as good shape as possible. There are updates for clarifications, like how do we achieve the symmetric paths. This was not made clear in the former versions, that in case of different link metrics in the 2 directions of a link, we use the maximum one, and we use the tie breaking used by SPB for equal cost paths. And there were also further updates on the MRT aspects, further clarification, and there is one new thing. The previous documents only described the case when, so one of the mechanisms is when the topology subtheory is used to describe the so-called GADAG, the generalized almost directed acyclic graph. And in a simplest case, it consists of a single block. But for instance, if the physical topology has cut links, then it is split into multiple blocks. And this new revision of the draft covers the multi-block case as well. Next slide, please. So this is a summary on the sub-TLVs. As I said, this is extension to SPB. We reuse SPB TLVs as much as possible. These are the top ones, and a summary on the new TLVs being specified by this draft. And the next slide is the last one, just a quick summary. I pretty much said what in the top in the slide, that this is extension to SPB, reusing TLVs without protocol change. And the bottom is quite important. QCA is under final review, and we would like to move forward with this ISIS PCR draft here. It would be good to have a working group adoption and early allocation for the code points of the sub-TLVs.
Okay, so here would be a bit the roadmap on progressing this further. So this is not really a classical IETF document. So I would like to start the working group adoption call right after this meeting. We'll give it some period, the usual 2 weeks. And then I would like Janusz and friends to initiate the early allocation procedure, such they get their code points, which are going to be valid for at least 1 year, and throughout Prague and Yokohama, we progress the document further and well, send it to IESG for publication. So if you have any concerns about the way you're progressing things that way, please speak up. On the list, of course, as well.
Okay, thank you.
Is Tony here? Which one do you want to do first?
I think it's the beer.
Beer auto BFRID or beer? PowerPoint?
Morning, everyone. I'm Tony P. 2 questions. First, who read the update on the beer ISIS, the 02 that was published in the meantime? Okay. Yeah, okay. Huge response. Who read the auto allocation procedure? No one read it. Okay, good. Next one, please. So this is basically what happened between the 001 and 02 to support beer via ISIS. So basically, it was all aligned with the architecture work that ICE and a couple of other people, Eric and me, did. Subdomains have been introduced. That's the biggest one. Subdomains are mapped to topology, and all routers must agree on the mapping. So the subdomain belongs to topology. Subdomain has a single encapsulation. I'm still poking the architecture people to spell it out specifically, because theoretically we could do encapsulation translation on beer within a subdomain. Subdomain has a single tree or forwarding strategy, so that is implicit in the architecture. But I'm being poked and poked by more and more people whether we could run anything else but SPF, so I wanted to keep the draft open enough so that it's not excluded. What was added is that any router not advertising enough labels for all the BFERs will be ignored in the computation. That's something I basically wait for implementation and deployment experience, whether people want that or not. Good. So basically, the new stuff is that the TLVs have been reordered under multi-topology. We now have the subdomain, and within that we have the encapsulation enough labels, and we have an optional sub-TLV to indicate the tree type. And when it's omitted, it means SPF implicitly today, so it's spelled out. But it can show up later, and the routers that run SPF today and see a TLV they don't understand for the tree will know that they cannot participate. Next one, please. All right, and there is, I introduced something which is an experimental idea. So one of the things that I have some discussions with people about is that when you get enough deployment in terms of size, and we need a lot of PFER bits, whether an automatic assignment makes sense. And we were not doing that on TLVs, but the idea would be that we can put on a TLV a minimal and maximum version number of what protocol version this TLV represents. And with that, without introducing a completely new TLV, we can progress the TLV and indicate to previous routers very precisely in which range they have to work version-wise to be able to interpret this TLV. The biggest advantage is that routers who run a newer version could run this TLV at a newer version, indicating a newer version with new information which all routers do not understand, and fall back. Once they have enough information, publish it at the lower version of the TLV, allowing all the routers to participate. Okay. Next one, please. So the first one is the sub-TLV, beer sub-TLV. So we have type length. Now the version with the compatibility bit, maybe min-max version. No, any discussion on the stuff. Subdomain ID is under it, and the BFR ID, which can be empty. Under that, we have the encapsulation. That's the MPLS encapsulation, which has label range size, what is the bit mask length, because the architecture changed in the sense the subdomain can support multiple bit mask length, so it's a list. And to the very right squeezed in is what tree type this subdomain supports. When it's missing, it means SPF, but in the future, when this TLV, well-known sub-TLV will show up, routers will understand that they cannot participate because it is not SPF. So if people start to build Steiner, I also basically indicated that they will put enough opaque data to actually all agree, you know, what kind of Steiner they're running. So that's pretty much the update. Let me take the questions now towards that, if there are any. And then I quickly basically just run through the idea of the auto-election, because if people didn't read the draft, it's pointless to like go into more depth. Questions?
AC Lindum, Cisco. The only thing I'm wondering about is the terminology. You know, the segment routing draft uses algorithm, and this uses tree type.
Oh, I wasn't aware of that. Okay.
For somewhat the same thing, and maybe
Okay.
maybe they should be aligned.
Okay, yeah, point taken. I will align the stuff. All right. I mean, there's no particular preference.
Hannes Grela, Juniper. It's actually first time that I saw using versioning inside sub-TLVs. I was under the impression that the versioning tool is actually a TLV or sub-TLV code point.
Yes.
Any reasoning why you ended up with that solution?
Yes. Imagine that I want someone to implement the absolute minimum set, and then I want something which does a smart election. After the election ran, I can show people the old style TLV. While the election is running, I want to tell the other routers back off. It looks like the format you understand, but I have sub-TLVs inside. If you don't understand them, you screw up. So I use exactly the same format, but I bump up the version to 0.1. I say, if you don't speak 0.1, don't look at the TLV. The moment the election ran and I have all the information that makes sense in 0.0, I just drop the version on the TLV to 0.0, and all the old style routers participate happily. So that allows to not every time you put a sub-TLV which may other people, old style people, screw up, I don't have a new TLV type.
I see.
Right.
You're using it for atomicness semantics,
Yes,
right?
absolutely.
Yeah, okay.
Yes. So, you know, it's an experimental idea, but since we have this auto election, and I don't want to force people today to understand, implement, do anything about it, I want a future hook to people operating on the same TLV format being able to participate it after the smarter guys figured out their stuff. I mean, it's exactly the same idea as shared libraries of Linux, right? Mm-hmm. You load the library and it tells you, I'm a 3, but I can really also talk 2 to you. But please, I cannot talk 1.
Mm-hmm. So, I mean, my first thought was, wouldn't you just use 2 TLVs and then back up to the old one after?
That's the other possibility. Yes. So basically, you have even maybe the same format, but you change the TLV type, and you talk those TLVs, and then you publish. And worst case, you end up with 2 versions, right? Like old version for the old routers, new version for the newer routers. Yes, so that's kind of the simple, naive way to do it, right? Which is more implementation, more TLVs, more data published. So, okay, Chris?
It seems like an interesting idea. As making it experimental seems reasonable, but at actually sort of sharing the data that you. So my concern about it is that you actually sort of broaden the testing space for compatibility testing. That you actually, you know, even when you don't have versioning, often a lot of problems are discovered during interrupt testing, even with things that are supposedly the identical version. And now you've basically created a matrix of cases, you know, version 3 and 4 and 4 and 5 that need to work together.
Okay, I mean, the argument I would make, it is absolutely equivalent to having 2 TLV types. The TLV type 135 will indicate version 1, 136 will indicate version 2.
It's not quite that right, because you're sort of taking over and putting a value in that can be a lot of different values.
Yes, okay, if you go wild and do 1 to 4 and you want to do all the permutations, yeah. That's why I only gave 2 bits to a version. I can give 1. but then we can go from 0 to 1. That's about it. Sorry, we're out of runway. Les.
Les Ginsberg.
Who are you?
You want me to say it again?
He's a really nice guy.
Thank you. So 2 things, and this is something that, you know, we are still kind of actively discussing even among the co-authors. You're essentially making the version number a new type that has to be controlled. That was where we
For
normally
observation, yes.
allocate code points.
Yes.
The other thing that concerns me is how you define the transition strategies as old or new routers appear and disappear in the network, and you're able to move forward or backwards on your version numbers. I think this is always problematic.
Okay, fair observation. Yeah.
And if we're going to do this, I think we need to do a better job of specifying how that happens.
Yeah, fully agree. So, I mean, this is something, yes, it's a completely new idea. I'm throwing it at the wall. I want actually people to go, you know, beat me up and see how bad it gets, right? And after the idea is socialized, maybe they find the bits they like and the bits they don't like, and we basically have the trade-offs. And otherwise, there's always the fallback, like, okay, let's get a new TLV time number. Okay. So yeah, the discussion, I want to pick up the discussion, right? And I want to show a feature that will benefit from it so people understand that it opens possibility to do those things on the protocol we couldn't do currently, right? Today we just basically say, well, all the sub-TLVs, if you don't understand them, just keep on going. And if someone introduces the one that breaks things, he better explains very well, and then ultimately somehow at a certain point in time cuts over to a new TLV type. Okay? Fair enough? Okay. So then I think next presentation I very coarsely explained the idea of this auto election, how that would run with it, and so whoever's not that familiar with beer, the very short summary, the receiving routers need a bit allocated in a bit mask. And the idea currently is that as long as deployments are small enough and stable enough, it will be a manual configuration. If there's a collision, there's notification. People take care of it, or maybe a central controller. This proposes something akin to a designated router, right? So people have a central authority they can get bits from. Or it's more maybe, a better analogy is a DHCP server. All right. Next one, please. So now that we have some domain and topologies, okay, and those number of the BFERs can go pretty big because we have the sets. So basically we are not constrained by the bit mask length up to reasonable size. We may be talking low number of thousands for sure of receiver bits. So manual configuration at a certain point in time, if this technology is successful, will become infeasible, right? Otherwise, we will be all still assigning IP addresses by hand, right? Work like a charm, or FTPing an ETC host. So it always ends up on a centralized and distributed solution. The centralized solution is probably something akin to SDN controller, right? Which is just fine. Single point of failure, if you replicate them, you have split branch scenarios, that's its own limitations. A distributed solution is far more resilient. I mean, that's why we're here, right? Working on protocols like this. Of course, always additional complexity. Next one, please. All right. So the whole thing is, the main thing, it is completely backwards compatible to the drafts that to support beer over ISIS. So people can today implement what the draft ISIS beer says, and when this thing is slid into the network, they won't realize the change. There will be old-style routers not supporting anything new, and they'll be participating just fine, and their assignments will be fully honored. Okay? The trick behind the whole thing is pretty much that there is a per subdomain, whatever, nicely spread out, designated router, backup designated routers. Lots of that stuff is stolen from John because it's so stable. And this thing will act as central authority. So the routers can signal on the TLV saying, give me an assignment, and that's the one I would prefer. And what they get back from the designated router will be basically a bit assignment for it, or an error, or whatever, all kind of conditions. Next one, please. I won't even go how many sub-TLVs the things entitles, so the DR basically puts out something which has the assignments in it, and on the normal info TLV, people set a bit to signal, give me an assignment, or they say, I have an administrative assignment. The version number, as long as the assignment is going on, the router will say, I'm at version number 1. If you don't understand version number 1, please don't look at my advertisement. The moment the assignment is stable, they put the assignment into the format and say I'm at version 0, which means all routers can perfectly well work with it. I think that's the last one. Next one, please. I think that's it.
Yeah.
All right, so that's coarsely the idea. If there are any comments towards that. You have one more?
AC Lindum, Cisco. The only thing I'm thinking is if you're setting up subdomains, you're going to have to decide what routers participate in every subdomain. And when you're doing that, you could just as well give it an ID, because I think this is only half of the setting up a subdomain and anything, unless subdomains unless you envision a deployment scenario where subdomains come and go dynamically.
It will depend how people deploy services over subdomains. But basically what this thing takes is one configuration step out. So you say, I'm running a certain service. Now, came to me, I would provide default subdomain mappings. I run a VPN service, I end up on this subdomain by default, okay? Which may or may not happen. But when you mapped onto a subdomain, that would be the only configuration step. Today you have to provide a non-colliding BFER, so the bit for the subdomain. So that saves this configuration step. Now, deployment simplicity versus protocol complexity, the usual trade-offs. I mean, this is nothing, that any kind of magic wand or whatsoever. More comments? I'm done. Thanks for your attention. I hope it was entertaining.
I took some notes, so I think let me copy those. Yeah, 1 second. Hang on.
Did we open your garage door?
Yeah.
Can you do prefix attributes last?
Last?
Of the thing?
I said eject. I'm just waiting for it to eject. Prefix attributes last. Yes.
It's true, actually.
So, what order would you like? Reverse
Just
order?
prefix attributes last, please.
SBFD.
The other two, I don't care.
Okay. Let's go in reverse order then.
Okay, this is going to go pretty fast because all of these drafts have been presented before, so these are just quick updates. SBFD discriminators next. There was one change, which was there was a conflict in the suggested code point with one that had been suggested in the segment routing draft, so I've resolved that conflict. That's the only change since Honolulu. As far as we're concerned, the draft is complete, and we're going to ask for last call once the base SBFD draft goes to last call in the BFD working group. We don't have to do the rest.
Yeah.
I left this in. This has been presented before. Any questions about the SBFD draft? Okay. Next. Okay, preference draft. Next slide. Again, this is complete. There have been no comments since Honolulu. We're delaying last call because there is a dependency on the prefix attributes draft, which is the next thing I'm going to talk about. So again, that's all I have to say about this, unless anybody has any comments about route preference. Okay, prefix attributes. Next slide. Since V0, there's been some editorial cleanup. The biggest issue was there were two proposals. There was a competing proposal as far as advertising multiple node addresses. There has been a discussion between the authors of both drafts, and we've reached agreement that we're going to use the solution in the prefix attributes draft. Next slide. So I put this in red because there are two documents that are dependent on the progress of this document. One is the route preference draft that I talked about before, and the other is the segment routing draft, because some of the bits that we're defining for prefix attributes are also defined they were originally defined in the segment routing draft. We moved them here because they have applications outside of segment routing. So the plan is to eventually deprecate the duplicated bits in the segment routing draft, but clearly we cannot do that until people can actually go ahead and implement the prefix attributes draft, which means we want to become a working group item. We want to get early allocation of code points as quickly as possible. So I would really like to progress this as quickly as possible. And that's all I have. Any questions, comments?
Is there anyone in the room right now that objects to this becoming a working group document? Raise your hand, anything? Okay. I think we'll take it to the list then and ask for adoption. Make sure you stand in the pink box.
Hello everybody, my name is Uma. Today I'm going to present encapsulation capabilities in ISIS. Next slide please. So this is not specifically for Spring. Originally this is envisioned for Spring incremental deployments. We have few use cases. My interest in this draft was few use cases where small routers where we don't have MPLS, but we want to do traffic engineering in mobile cell stations where only you have is routing capabilities, but on the edge nodes you can put a Spring and a controller can put the paths, explicit paths, and divert the traffic. So that was my interest in this draft. So later on there are a couple of other use cases where incremental deployment is needed, and like beer, where you don't support MPLS and just pure IP, but on the edge nodes you have MPLS capability with segment routing with beer. So in these kind of situations, advertising the decapsulation capabilities of the egress node will be very useful. So this draft is about advertising those capabilities in IGPs and especially in this case ISS. So the new use case was remote LFA case in pure IP networks where PQ node want to advertise its decapsulation capabilities to all the P-space nodes. This is not documented in the draft. This is still in discussion. Bruno suggested this and we will work on this. Next slide please. So as I said, this enables ingress IP-based tunnel to know which encapsulation type to use, and this has a huge advantage. And in operations, basically, you need not config any type of stuff, on each node like admin tags, that kind of things, basically. Next slide, please. So what we are asking is a sub-TLV in the 4971, which specifies the encapsulation capability. Basically, it's a decapsulation capability to be specific of the egress node and the associated parameters for that decapsulation capability. The current we only in the current version of the draft, we only support only MPLS encapsulation. We didn't put IP encapsulation set, so the list will be updated. Next slide, please. So we thank Bruno for his thorough comments and new use cases. We'll work on this to be done, adding a remote LFA use case, encapsulation types review, and sub-TLVs in the encapsulation sub-TLV type to indicate the parameters, certain encapsulation types, for certain encapsulation types like IP address, GRE key. And we look for more inputs and comments.
There's no square here. This is Ahmed Bashandi, Cisco Systems. So Uma and I talked about this, and I had two comments. First of all, this is a general problem that is not really related or specific to segment routing. It is more of a how do I bridge two MPLS islands over an IP island. And it is not specific to remote LFA or how to decide the PQ node. Again, it's a general problem, how do I choose the PQ node. The third comment is that this is about a 20-year-old, maybe 15-year-old problem since the creation of MPLS when it was called tag switching. And I am sure people have solved this problem, how to bridge two MPLS islands over an IP island without the need to extend routing protocol. And one way, as I suggested, to do it is to use admin tags. There are other node admin tags or prefix admin tags or configuration. In other words, I don't see a need for such extension for a problem that existed 15, 20 years ago and nobody has objected to its existence or even mentioned its existence. Thank you.
Xiaohu from Huawei, another call service dropped. In fact, OPSI 5512 has defined approach for dynamically advertising encapsulation capability, or BGP. Now this drop is to extend ICE to do the same thing. The rationale for this is in some scenario, BGP is not used, so it's straightforward to extend ICE to do that work. For example, in the incremental deployment of the beer, there are no BGP enabled. ICE is used instead, so the drop is to support that scenario. Thank you.
Les Ginsberg. Just in the vein of brainstorming, Ahmed has suggested that prefix admin tags could be used to do this. One potential advantage of using prefix admin tags, which I think is something dear to your heart, by the way, Uma, is that it would also implicitly tie the endpoint address that you want to use to the tunnel type. Just a thought.
So I'll answer both the questions. First, for your question, we can use admin tags, but it requires changes in the code to associate. Typically today, admin tags used for basically for redistribution. You stick a tag on the prefix, and that prefix is the attribute for your stuff or for redistribution between the levels or leaking that will be used. That's all is there for today. And if you want to put associated parameters, probably if you were tunnel type, it requires particular IP address, you can use it, but it cannot be generic. And it requires code change. It's not straightforward, actually. This is a straightforward approach. Anyway, that also, a code change is required. This is a more straightforward approach, more generic approach.
Sorry, I mean, we can take this to the list, but
Sure.
for the record, I
Definitely.
don't think it's that difficult.
You cannot put a GRE key, for example, on an admin tag, actually.
Xiaohu from Huawei. In fact, I have noticed there are attempts to use a different way to advertise node capability. That is to use the prefix based TOA. I think both the ISS and the OSPF should seriously consider whether we need two different approaches to do the same work. Thank you.
The point that I'm trying to make is that we are trying to solve a 15-year-old problem that nobody has complained about. I am not sure why it popped in the past few months.
So Ahmed question, actually we discussed Ahmed on this very elaborately. So as Shia mentioned, non-BGP environment is useful. For me, the segment routing use case is when explicit path is crafted by a controller and put it at the ingress node. When a node encounters the neighbor is not Spring or Beer capable, we don't know what we need to do if BGP is not there actually. So immediately if you know the tunnel endpoint and its capability is with you at the ingress node, it's quite useful and automatic actually.
I would like to repeat, this is Hannes, I would like to repeat the comment that I gave in the OSPF working group. It looks to me that this is the formal equivalent of the tunnel SAFI, RFC 5512. I do not really see that this is an unsolved 15-year-old problem. It's actually a solved problem, and my understanding is that Yuma tries to put the tunnel encapsulation semantics now down to the IGP level.
Maybe I wasn't clear. This is Ahmed Bashandi again. The problem of islanding two MPLS islands over an IP island in an intra-domain and an IGP domain existed 15 years ago, and nobody has complained about it. What you're referring to is BGP, and I agree BGP was solved, but it's a different problem.
I wonder whether you have noticed that there are sections in the beer architecture draft which talks about incremental deployment of the beer technology. In that section, it said if the next hop to the final BFER is a non-BFR, that BFR could tunnel the beer packet directly to the BFER, either via RSP or IP-based tunnels. If IP tunnel is used in that case, do you suggest to use BGP? Do you suggest to establish BGP sessions between all nodes within the beer domain?
Tony P. So whether a router supports beer can be very easily derived from the fact what it announced beer info sub-TLV, right? That indicates to you that it supports the encaps as well.
There is no support in segment routing like that.
Hold this. This is Ahmed Bashandi one more time. But the point is that we are extending the protocol with new sub-TLVs, which is not a straightforward sub-TLV. It will require configuration. So the same configuration effort is needed, or actually less configuration effort is needed by using admin tags. You can achieve the same exact result with admin tags. You go to the routers, configure them for admin tag number 10, use GRE, admin tag number 11, use L2TP, so on. And on the endpoints or the decapsulating points, 10 for GRE, 11 for L2TP. Same thing. And admin tags has been around, I don't know for how long. So the amount of code, if we need code for this, if we need code for admin tag that has been 10 years ago, we definitely need more code here.
Ahmed, there is actually people who are doing TE controllers these days who keep telling me it all can be solved with static routing, so you don't really need dynamic routing protocols at all. So, obviously, tags, generic tags, node tags, prefix tags are sort of last resort exits for solving a problem. The problem that gets a bit lost is that they are context-free, so those tags do not really have any semantics. And I think since this has data plane implications, they would like to carry on those semantics.
All right, well, this was an interesting discussion that maybe we'll publish on the list as well to get everyone's opinions out there. But I think, Les, you were suggesting something similar with tags. Yeah, okay. All right, thanks.
Yeah, thanks, Chris. Thanks, Hans. Thank you.
Good morning, everybody. I'm Shraddha. I'll be talking about the link overload feature in ISIS. A similar feature draft was described in OSPF working group as well. So this is a same feature being protocol extensions for the same feature in ISIS. Next slide. So we have the node overload feature wherein you can set a node to overload before bringing it down for the maintenance. So here we're trying to extend the same functionality to the overlay networks. So this diagram shows a typical overlay network wherein the CEs are connected over an overlay, so the PE devices are not visible to the CE devices. So when the PEs go for maintenance, before taking it out for a maintenance, you need to divert the traffic from the link to the other link, which is an alternate link. So if P1 is going down for maintenance, traffic from CE Blue 1 has to get diverted via PE2, the link which is via PE2, and similarly the traffic from CE Blue 2 need to get diverted via PE4. So whereas it's easy to divert the traffic from CE Blue 1, it's difficult to do the same on the from the remote side. So generally you need to do manual configuration on all the remote ends to say to divert the traffic to the other link. Next slide, please. So we just described in the problem that manual configuration is difficult, and the next slide, please. Okay, this is a similar problem described for the overlay broadcast networks. This is an overlay network over IRB interfaces, wherein the CE red devices here, they appear to be in a broadcast network. So here also the problem is same. If P1 goes for maintenance, you probably want to divert the traffic before the P1 is taken out for maintenance. This is useful if operators want to give it as a service to the customer, that they will make sure that traffic is diverted before the PE is taken for maintenance. Next slide, please. So the motivation is ease of maintenance, automated upgradation, and minimized traffic loss. Next slide, please. So what we are suggesting is to carry the link overload bit in the link attributes TLV, sub TLV, which is RFC 5209. So just define a bit in the link overload, link overload bit in the link attribute sub TLV and carry it along with the IS extended reach TLV, which is TLV number 22. So the receiver, it identifies the connecting link, increases the metric to max metric. So this metric needs to be a usable metric so that in case there is no alternate path, traffic still continues to flow on this. And then refloods the LSB, and traffic is diverted away from the overloaded link, and then link is ready for maintenance. Next slide, please. Similarly, for the broadcast links, the DIS for the link just removes, DIS for the link updates the max metric for the originating node, and then refloods the pseudonode LSP so that, and the traffic is diverted away from that link, and then the link can be taken out for maintenance. So this is the RFC 5209 defined link attribute stub TLV. So the switch is defining a bit in the flags.
Questions, comments?
Les Ginsberg. So, a couple of questions. One, why would you put this bit into the LSP advertisement rather than the hello, given that the only person or the only node that's going to do anything about this is your neighbor?
Yeah, that's true. Only the neighbor would act on this, but since we can reuse the existing TLVs, and it's just a bit, so I think it's not very difficult if we define the procedure that only the remote end of the link is going to look at it. So it's the same thing. So only the neighbor is going to act on it.
Well, one of the consequences of putting it into TLV 22 is if you have parallel links to the same neighbor, you're now forced to advertise, and they're equal cost. You're now forced to advertise all of them, which in some scenarios is not necessary.
So I guess the link, the TLV22 can also have sub-TLVs with interface address and the neighbor's interface address that will uniquely identify the link.
So that's quite true, but if I have multiple links to the same neighbor and they're equal cost, unless I'm doing traffic engineering, there's no requirement to advertise both of the neighbors. Because from the point of view of building the SPT, just saying I have a neighbor to B with a cost of 10 is sufficient. So to me, that's another reason why it would be much better if you put this in the hello. The follow-on to this is, I don't know if you're familiar with the reverse metric draft.
Yeah, I read it after your comment in the OSPF.
Okay.
It looks like it's doing the same.
So I mean, was it just that you weren't aware of it? Or did you talk to those authors?
It's expired.
Yeah.
Fair enough, but
do you want to resurrect it?
Well, in my opinion, and I was never a fan of the reverse metric idea, but
and now you're going to fight for it.
But no, I'm not fighting for it. But I'm saying, I'm saying, if we're going to do this, I believe the solution defined in the reverse metric draft is the correct solution. And oh, by the way, maybe those authors deserve some credit, so maybe you can collaborate. But that's not my problem. I just really think if we're going to do this, we should look at the reverse metric solution, and I think we should use it. Okay.
Uma from Ericsson. First, I have one small comment on the draft. Just a clarification. Basically, in ISIS version of the draft, you still talk about DR and BDR. Probably need to correct that language. So that's one comment. And regarding the reverse metric, the part reverse metric has a lot of concern for a lot of people was you are changing the metric of the other side on the fly. So people may not like it. Operationally, there's a lot of discussion in the mailing list. Probably you might want to see that. So this is another approach, I see. Thanks.
Pushpashish Juniper, question to Les. I kind of agree. The reverse metric does solve this problem, and I also agree to your comment that this should be only on the hello, need not be on the LSP. But I have a question to you back. Again, forgive my ignorance. Is there a reverse metric draft in OSPF?
No.
I think
but
not.
Could there be?
Yeah, that's what I wanted to actually say. So instead of resurrecting the reverse metric, we can actually have these two drafts already proposed across the two working groups. Or, I mean, that's the other alternative of adding one in OSPF for the reverse metric.
AC Lindum, your colleague has a very similar draft in OSPF where the encoding could be, we have the two-part metric, which is for certain types of so there is encoding for more than one metric. There is not per se a reverse metric.
Yeah, AC, the other comment I would make is it's a little more difficult in OSPF because you don't have a metric in the network LSA.
Yeah.
So for the case of LANs, we have to find some way to solve that.
So just my read of the room, how much of you are the opinion that we should have a comparable, if not identical, mechanism in the both IGPs?
Yeah, he's leaving that one open. I think he's trying to
trying just to get some sense. Yeah.
Yeah, you are. AC Lindum, we agreed to talk about whether this is really needed or not in the OSPF working group, whether this scenario, why you need to do this. not as opposed to how you need to do it. And that's the first, I think that's the first question. I mean,
Okay, I'll send the Verizon guys into your way.
What I think Hannes was going for is that we probably shouldn't have two different methods. It should be the same in both IGPs. Les.
Yeah, Les Ginsberg. I mean, what we've consistently done with these kinds of things in the past is we provide equivalent functionality, but the actual mechanisms in terms of encodings are what's best for each protocol. I don't see why we should deviate from that. And I think in this case, certainly for ISIS, if we're going to do this, the hello is the appropriate place to put this information.
Okay, fair enough.
Thank you.
Thank you.
Hello, everyone. My name is Huan Chen from Huawei. So today I'm going to talk about ISS topology transparent zone, shortly for TTZ. So give an introduction, extension to ISS, and then SSP updates for TTZ and adjacency with TTZ. Next. So as the network becomes bigger and bigger, and then we need to split the network into more areas. So when we do the splitting, and then we have some issues, such as the surface will be interrupted because the nodes or link with old area will going down, and then those nodes and the link with new area will come up. So during this process, the surface will be interrupted. So also for splitting network into more areas, we know this is a very big network architecture change. So this is a very, very challenging task. In addition, it's very time consuming when doing the split. So furthermore, maybe very complex for end-to-end LSPs. So TTZ will resolve these issues. In OSPF, we have implementations, and we have showed that OSPF TTZ can resolve these three issues. So with OSPF TTZ, so we show that we can transfer a part of network smoothly to TTZ without any surface interruption. Also, when we do the transformation, the operation is very simple. So also the OSPF TTZ is a working group document right now. So next slide. So TTZ, is a virtualization technology. It virtualizes a part of network as the edges of this part fully connected. So this part of network we call the TTZ, topology transparent zone. So outside of this TTZ, any node outside of TTZ is not aware of TTZs. So it will only see the edges fully connected. We'll see this virtualized topology. So those links inside the TTZ, nodes and the link will not be advertised to outside of TTZ. So next slide. Next one. So to support ISS TTZ, we just need one TLV called the TTZ TLVs. So TTZ TLV contains some flags and a TTZ ID, and then a couple of sub-TLVs. So for flags, so this is just a copy from OSPF. So we defined 5 flags. So one flag is that E flag is the edge router of TTZ. So this flag indicates this router is an edge router of TTZ. And then this 4 flag is just for migration, a part of network to TDZ, and then some of flag is used for root back TDZ to the normal network. For example, for migration, a part of network to TDZ, we just use 2 flags. One flag is that T flag for distribution of TDZ information, and then another flag is for migration, the data path of network into TDZ. So for sub-TLV, so normally we have one sub-TLV, which is TDZ IS labels sub-TLV. So next slide. So for TDZ IS label sub-TLV, it just consists of a number of TDZ labels. So next slide. So here we just give those how we use LSP to virtualize the ISS TDZs. So for each internal router inside the TDZ, so we just add TDZ TLV. So this TDZ TLV with E flag equals to 0, which indicates that this is an internal TDZ router. And also with TDZ ID, for example, with TDZ ID 100. So that's so for internal router is easy, just one TLV, TDZ TLV with E equals 0 and TDZ ID. So for any router, for any edge router of TDZ, so we just have its LSP with a TDZ TLV. So this TDZ TLV will have E bit equals to 1, which indicates that I'm a TDZ edge router. And also, it will have a TDZ ISN sub-TLV. So this sub-TLV will contain the TDZ labels. For example, here, this is an edge router of TDZ. So the sub-TLV, this sub-TLV will contain the label T1, and then the label T5, and then label TA. So with this information, every router inside the TDZ can determine the TDZ domain, can determine the TDZ. Because for each internal router, we have a TDZ TLV, which have a flag internal. So this indicates for internal router, every adjacent router is a TDZ router. So for edge routers, because we have TDZ ISN sub-TLV, this sub-TLV contains information about TDZ labels of these edge routers. So with this information, the whole TDZ is determined. That's for determine the TDZ. So for virtualized TDZ, we just add the other edges as IS labels. For example, here, for this edge router, we just add the other edge T1, the other edge T3, and the other edge T3 as IS labels. So with those information, any router outside can see this virtualized network TDZ. So this virtualized part, because this is just the normal IS labels. So from outside, it just see these normal connections. So from outside, it just see the normal virtualized network. It's not aware of any TDZs. So next slide. So for adjacency, it's simple. So when we configure TDZ, so we will add a TDZ TLV with a TDZ ID into hellos. So on both sides, if we decide that the TDZ ID are the same, and then we can form the TDZ adjacencies. So if they don't same, and then we don't form the TDZ adjacencies. So for a TDZ edge router, it forms adjacency with the router outside in the normal way, except that they just synchronize the database except those internal information. The internal information will not synchronize to outside. That's the only difference. So next page. So this page, we just show the operation of migrations. So for migrate a part of network into a TDZ, just follow these 3 steps, very simple steps, 3 steps. First, we just configure TDZ. So for configure TDZ, normally just 1 command on each of our TDZ routers. So for example, configure TDZ on this route, configure TDZ on this route, just 1 command. So after we configure TDZ, and then we just use 1 command for whole this network, for whole this part. This 1 command is trigger the TDZ information distribution, 1 command for whole part. And then the third step is that we use also only 1 command on any one of the nodes for migration of this part to TDZ. So 3 steps. That's from operation point of view, it's very simple and easy. So from inside, so after we configure TDZ, then we will discover TDZs. As I mentioned, just we put hello, put the TDZ TLV with a TDZ ID into hellos, and then we can discover TDZ adjacencies. And then after the first step, the second step is that every TDZ router just add TDZ TLVs into their LSPs. So this, at this step, so this corresponds to the second step. So the TDZ information will be distributed in the network. So the TDZ will be discovered and determined. And then the last step is that we use 1 command on any one of the routers of TDZ, migrate this part of network to TDZs. So for this command, this will trigger the AG router to virtualize the TDZ. So the AG router will add those kind of virtual labels, means the other edges as their IS labels. And then also, it will not distribute the TDZ information to outside. So that's done. So we can see that those 3 steps from outside and the 3 steps from inside, and then the TDZ is transformed without any surface interruptions. And also, the operation is very, very straightforward and simple. So next step. So next step, we would like more comments from the working group.
Les Ginsberg. It is possible today with the base protocol to quite easily and non-disruptively merge and split areas. We don't require any extensions in order to do that. It derives from the fact that you can configure multiple area addresses on a given box, and when you do, they become synonyms for the same area for all the routers in that area. I won't spend the time in the meeting to go through the steps, but it's very straightforward to split one area into 2 areas, for example, non-disruptively, with existing functionality in the protocol. So with that in mind, it isn't clear to me why we would invent another extension to do the same thing.
You mean, so you will not bring the link down with the old area, you will not bring the load up with the old area, we just...
You can do this non-disruptively.
So you can give more details, and then we can go...
Yeah, I mean, I'd be happy to discuss that with you, but it's a well-known procedure.
Okay.
Long Wei from Huawei. So actually, this can solve much more than you just described. And for example, recently I saw an operator, they have a network. So they upgrade from one company's routers to another company's routers. But somehow in their POP, they forgot to take some old routers out. So routers still there, but it's misbehaving. So, but if they configure TDZ, something like that, so the those link state advertisement will not be popped out, so it can minimize the it can minimize the service disruption. And on the other hand, and this technology and this extension can reduce your topology complexity, because without it, and your topology, the tables may be bigger. So there are multiple applications. It's just not only for splitting your network into smaller ones.
This is Hannes. I do not really quite agree using vanilla mechanisms it can be done, but I certainly would agree that, for example, using multi-instance ISIS to model a TTC zone, it could be done, right? So either way, I think there is already some tooling that we have in the toolbox to sort of model those zones, and I would like to see rather reuse of those tools than to reinvent something new.
Yeah, we would like to look at those tools, but I don't know whether that tool can replace or all the functionalities here.
Well, why don't we, I mean, given what Les is mentioning about the multiple areas and stuff, why don't we take this to the list and flush out whether we can solve this problem with what we have already?
Okay. Yeah. Thank you.
Thank you. I think that's our last thing. Yeah, so that was our last presentation. Does anybody have anything else to add to the meeting? All right, great. Thanks a lot.
See you in Prague.
Hopefully on a different day than Friday. I really worked hard to try to have it not happen this time, but I'm going to put almost zero conflicts down. Yeah, that's true. So you were the alpha, we were almost the omega. Yeah. Oh, the afternoon one? Oh, yeah. Right. The penultimate.
And then there was this sales conference.
Were they waiting outside the door? Right. This is our room, like. Can you please get out? You could tell they were all charged up for the motivation. Right. Oh yeah. What's that? Yeah. Oh. If anybody didn't sign the blue sheets, could you come up and sign? And I think there might be a blue sheet out there somewhere. Ah, okay. Uh-huh. His 15-hour battle? No. Yeah. Well, I'm gonna, he's gonna make me. I've got like a half an ISIS on GitHub too. Like, but now I'm gonna. If his is pretty, I'm gonna have to clean mine up. No, it's on GitHub. So I did. On mine. I actually went. So Linux specific standard package. So it doesn't have to. Doesn't have to be any IO. Oh, that's why he's using 3.4. Yeah, he's probably using like asynchronous or whatever. Anyway, I did it with memory views, so I'm actually doing like 0 copy. And Python loves to copy, right? So I'm using memory views, and I did a C library extension so that I can actually poke within that memory view. So I get the frame from that link, and I never copy it. Like I just carry that memory buffer, because that's where I thought, like, if I'm going to see any kind of serious degradation in performance with Python, I thought it's probably going to be from copying things all the time. So I said, let me focus on minimizing that, because what I really want is a Python ISIS that actually performs as well as a C version, or close enough so you don't notice, right?